Okay, let's have a look at the first of these circle theorem examples. The idea with all of these is to move known angles like this 58 or 78 or 34 to other places in the diagram using one or other of the circle theorems here on the right. I think the first thing to notice, and it's said in the question, that we've got a cyclic quad. So that brings in rule number 7, in the opposite angles of a cyclic quad at up to 180 degrees. So we can certainly move this 78 and calculate this angle up here. The other thing to notice is that the line BD does not go through the origin, so we cannot say that this angle here, the angle BCD, is 90 degrees. Employing the cyclic quad rule, we can say that 78 plus our unknown angle, let's call it x for the moment, is equal to 180 degrees. Therefore, x is equal to 180 minus 78, giving an answer of 102. So we found our first angle, and this angle up here is 102 degrees. Now, without any circle theorems at all, there's a couple of angles we can put on. There's this one here, and there's this one here. The first one being the simple addition of 3 angles in a triangle must add up to 180 degrees. So we can say that 34 plus 102 plus, let's call it y, is equal to 180 degrees. Therefore, y is equal to giving an answer of 44 degrees. So this angle here is 44 degrees. Actually, I haven't even found out what we actually want to do in this question. We need to prove that AB is parallel to CD. So this one here is parallel to CD. But let's go on with our angles for the moment. The other angle we can find is this angle here, which we'll find from the fact that all angles on a straight line must add up to 180 degrees. So we can say, therefore, Z is equal to, well, that again equals 44 degrees. So we're beginning to get equal angles from our calculations. So let's pop that on the diagram. This angle we've calculated to be 44 degrees. Now, does that get us anywhere in proving that our 2 lines that we need to prove are indeed parallel? Well, we need to employ one more circle theorem. And to move 44 to somewhere else in the diagram, we have to employ circle theorem number 8. The angle between the chord and the tangent is the same as the angle standing on that chord to the circumference. Okay, here is the chord, and here is the tangent. And the angle between that chord and that tangent is our friend 44 degrees. And the angle standing on the chord AD is this one here. So this is 44 degrees as well. Now we've got a lot of 44 degrees around the place, but the important ones are this. There's a geometric Z here, down line CD, across here, and then along line BA. It forms a Z. And as these alternate angles are equal and a perfect Z is formed, these lines must be parallel. So that is indeed parallel with that. The line AB is parallel to DC, which is what we were asked to prove here. So we've done it.